Hello friends, today we are going to discuss problem based on main dimensions. First, we read the statement of the problem is determine the main dimensions, that is D and L. We have to find turns per phase, that is TS, number of slot, that is number of slot SS, conductor cross section, that is small as, and slot area, that is ASS. We have to find these things. For 250 HP, that is motor output is given 250 HP, 3 phase 50 Hz, F is equal to 50 Hz, stator voltage, that V is equal to 400 volt, voltage is given 400 volt, 1410, that is N is equal to given 1410 RPM, slip ring induction motor. Assume specific magnetic loading 0.5 Weber per meter square, that is BAV is given 0.5 Weber per meter square. Specific electric loading, that is AC is given 30,000, AC is given 30,000 ampere per meter. Efficiency and power factor is given, that is 0.9. Efficiency is equal to 0.9, power factor, that is cos phi, is equal to 0.9. Winding factor 0.955, that is kW, winding factor is given 0.955. Current density is 3.5 ampere per mm square, that is current density denoted by delta is given 3.5 ampere per mm square. The slot space factor, which is shown by SF, is 0.4, and L by tau, that is ratio of core length to pole pitch, is 1.2. L by tau is equal to 1.2. The machine is delta connected, that is connection delta. Assume 5 slots per pole per phase, that is Q is given, slots per pole per phase is 5. Now, first we will understand how to solve the problem. To find D and L, first we will find Q, that is rating of motor in kVA, but in this problem the motor output is given in HP, therefore Q is HP into 0.746 divided by efficiency into cos phi. From this we will find the input kVA of the motor, that is Q is equal to speed is given 250 into 0.746 divided by efficiency and cos phi is given 0.9. The next step is to find C0 is equal to 11 BAV AC kW into 10 power minus 3. Now have the values of BAV, magnetic loading, that is 0.5 Weber per meter square. We have the value of AC 30,000, kW is given 0.955, that is winding factor is given 0.955 into 10 to the power minus 3. In this way we will get the values of C0. Third is small ns. In this problem the motor speed is given, that is capital N, actual speed is given, N is equal to 1410 RPM. From this we will get the nearest synchronous speed, that is nearest synchronous speed ns. We will assume that this ns is equal to 1500 RPM. From this we will get the value of P, that is ns is equal to 120F divided by P. We have the value of ns, that is 1500 into is equal to 120F divided by P. From this we will get the values of P, and small ns is equal to capital Ns divided by 60. In this way we will get this small ns in RPS, that is revolution per second. Now we know the relation for Q is equal to C0 into D square L ns. We have the value of Q, input kVA. We know the value of C0, that is output coefficient, small ns. From this we will get. From this we will get the equation for D square L, that is equation number 1. Now to separate this product D and L, we will require either peripheral speed or ratio of core length to pole pitch, that is L by tau ratio. In this problem, the ratio of core length to pole pitch is given, that is L by tau is equal to 1.2. L by tau is equal to 1.2. From this, we will get the values of D and L. But in this problem, we also require to find, that is number of stator turns, number of stator slot, cross-sectional area of stator conductor and area of stator slot. Now, to find number of TS, we know the relation, that is ES is equal to 4.44 F phi m TS kWs. In this equation, we have the value of ES, that is voltage 400 volt is given, 4.44, F is given 50 Hz frequency, but we don't know the values of phi m and TS. kWs is given, that is winding factor is 0.955. Therefore, first we have to find either phi m or TS, but we know the relation for phi m, that is BAV is equal to phi p divided by pi dl. From this, by phi is equal to BAV into pi dl divided by p. We know the value of we know the value of BAV, that is 0.5 Weber per meter square. Value of pi is 3.14. D and L we already find from fifth step. We have the value of P, that is number of pole. From this, we will get the value of phi. Now, we can calculate value of TS is equal to, therefore TS is equal to ES divided by 4.44 F phi m kWs. Now, we know the values of ES, F, phi m and kWs. From this equation, we will get the values of TS. Now, from this TS, that is stator turns per phase, we can find total number of stator conductor, that is ZS is equal to M into 2 TPH, that is M is 3 into 2 PH, that is ZS is equal to 6 TS. We know already the values of TS. From this, we will get the values of ZS. Now, next step is to find the cross-sectional area of conductor, that is AS is equal to, we know the formula for AS is equal to IS divided by delta. In given problem, current density is given, that is 3.5, but we don't know the value of IS. To find the value of IS is equal to Q into 10 to the power 3 divided by 3 ES. We already find Q is input kVA into 10 to the power 3 divided by 3 into ES. The value of ES is 400 volt, which is in given. From this, we get the values of IS. Now put the value of IS in above formula, that is IS divided by delta. We will get the values of AS. Next, to find slots, total number of slots, that is slots per pole per phase, that is into number of phase into number of pole. From this, we will get the number of stator slot. Now, the last step is to find area of stator slot, that is ASS. The formula for ASS is equal to ZSS into AS divided by SF. AS is a cross-sectional area of conductor. We know the value of AS from this formula. Then SF is given, that is space factor in given data, that is 0.4, and the value of ZSS is conductor per slot. ZSS can be found by using ZS divided by SS, total number of stator conductor divided by total number of stator slot. ZS is found by using this equation, ZS is equal to 6 TS, that is stator turns per phase. From this, we will get the value of ZS, and number of stator slot, that is SS, is found by using number of slots per pole per phase. Now put the values of ZS into in this equation, that is ZSS, we know the value of AS divided by SF. In this way, we will find the area of stator slot. Now we will solve the problem. The first step is to find the input kVA. Q is equal to HP into 0.746 divided by efficiency into cos phi. HP is given, that is 250 HP into 0.746 divided by efficiency and cos phi is 0.9. Therefore, by solving this, we will get the value of Q is 230.24 kVA. Now the next step is C0 is equal to 11 BAV AC kW into 10 to the power minus 3. The value of BAV, magnetic loading 0.5, electric loading 30,000 into kW 0.955 into 10 to the power minus 3 as it is. From this, we will get the value of C0 is equal to 157.57. Now in given data, the speed of motor is given, that is 1410 rpm. Therefore, the nearest synchronous speed of the motor is 1500 rpm, which is in revolution per minute, but we required revolution per second. Therefore, ns is equal to 1500 divided by 60. Therefore, small ns is equal to 25 rps, that is revolution per second. In this problem, we also required number of poles. Therefore, P is equal to 120 F divided by Ns is equal to 120 into F. The value of frequency is 50 Hz, and Ns, that is capital Ns, is equal to 1500. Therefore, number of pole is 4. Now, we will get the equation for d square L. Therefore, put these values, that is Q is equal to C0 into d square L Ns. Therefore, d square L is equal to Q divided by C0 into Ns. Now put the values of Q, C0, Ns in this equation. The d square L is equal to 230.24 divided by 157.57 into Ns 25. Therefore, d square L is equal to 0.0584 meter cube, since d diameter in meter square into meter cube, which is equation number 1. Now to separate this diameter and length, we required either peripheral speed or ratio of core length to pole pitch. But in this problem, ratio of core length to pole pitch, that is tau, is equal to 1.2. Value is given, therefore we use this equation. Therefore, L is equal to 1.2 into tau. The value of tau is pi d by p. L is equal to 1.2 into pi d divided by p. But we already find the value of p is equal to 4. Put this value in this equation. Therefore, L is equal to 1.2 into pi d divided by 4. The value of 1.2 into pi divided by 4 is 0.9424 and d as it is. Therefore, L is equal to 0.9424 into d. Now, the value of this L put in this equation 1 or substitute in this equation. Therefore, L is equal to 0.9424, d square L is equal to 0.0584. Now, the value of L is 0.9424 in d into d square d cube is equal to 0.0584. Therefore, d cube is equal to 0.0584 divided by 0.9424. Therefore, the value of d is equal to 0.395 meter. Now, this value of d put in this equation, that is L is equal to 0.9424 d. Therefore, L is equal to 0.9424 into 0.395. Value of d is 0.395. Therefore, L is equal to 0.374 meter. Now, to find stator turns per phase, we know the relation, that is ES is equal to 4.44 F phi TS kWs. In this equation, we know the value of ES, 4.44 is constant, F 50 Hz frequency, kWs winding factor, but we don't know the value of phi and TS. Therefore, first we have to find the value of phi, that is phi is equal to BAV into pi dl divided by P. This equation is derived from the formula of specific magnetic loading, that is BAV is equal to pi P divided by pi dl. Therefore, phi is equal to, the value of BAV is 0.5, pi as it is, d and L, we know the value of d and L is 0.395 and L is 0.374 divided by number of poles, that is 4. From this, by solving this, we will get the value of phi, that is equal to 0.0582 Weber, since flux in Weber. Now, the machine is delta connected in given, therefore line voltage is equal to phase voltage, VL is equal to VPH. Since we are getting the values per phase, therefore TS is equal to ES divided by 4.44 F phi kWs. Now we have the value of flux, therefore TS is equal to ES, the value of ES is 400 divided by 4.44 50 Hz frequency into flux 0.0582 into kWs is stator winding factor 0.955. From this we will get the value of Ts is equal to 32. Now to find the total conductor, that is Zs, Zs can be found by using 6Ts. This 6 is 3 into 2 into turns per phase, that is 3 is the number of phase, into 2, 3 into 2, 6 into stator turns, that is 6 Ts. We know the value of Ts is, that is 32, therefore 6 into 32, therefore Zs, that is total conductor, is equal to 192. From this we can find total slots, that is slots per pole per phase, that is slots per pole per phase, that is value of Q is given in data, that is 5, number of pole is 4, per phase, that is number of phase is 3, therefore 3 into 4 into 5, therefore number of stator slot is equal to 60. Now we have to find cross sectional area of conductor. The relation for cross sectional area of conductor AS is equal to IS divided by delta, that is stator currents divided by current density. In this problem we don't know the value of stator current, that is IS, but we can find stator current by using the relation IS is equal to Q into 10 to the power 3 divided by 3 into S. In our first step we already find the value of Q, that is 230.24 into 10 to the power 3 divided by 3 into ES, that is 3 into 400 volt. For 400 volt is in the given data, that is voltage. Therefore IS stator current is equal to 191.86 ampere. From this IS, put the value of this IS in above equation, that is AS is equal to IS divided by delta. In this way AS is equal to IS divided by delta. Stator current is 191.86, current density 3.5 is in the given data. From this we can find cross sectional area of conductor AS is equal to 15.8 mm square. It is approximately equal to 55 mm square. Now we can find area of stator slot. Area of stator slot ASS is equal to ZSS into AS divided by SF. This ZSS is conductor per slot, AS cross sectional area of conductor, SF is the slot space factor which is in the given data, that is 0.4. AS we already find, AS is a 55 mm square. Now conductor per slot can be found by using the relation ZSS is equal to ZS divided by SS. This ZS already find, that is ZS is equal to 6 into TS, that is 192 divided by number of stator slot, already find slots per pole per phase, that is 60. From this we get the value also is equal to 3.2, which is approximately 3. From this now put the values of ZSS, AS and SF in this equation, that is ASS. Therefore area of stator slot is equal to ZSS is 3, AS, that is area of cross sectional conductor 55 divided by slot space factor is given 0.4. From this we will get the value of area of stator slot is equal to 412.5 mm square. In this way we solve all the parameters which is required. Thank you.